Today we're going to be starting Unit 3 on trigonometry. Now this is one of my absolute favorite units in math. In Math 10C we just get a little taste for trig. We work only with right triangles, but the fundamentals that you learn in this course are going to take you further as we move on to other math courses, and not just math but also physics. By the end of this lesson, you should be able to identify the opposite, adjacent, and hypotenuse sides of a right triangle given a reference angle. You should be able to write your primary trig ratios for sine, cosine, and tangent. You should be able to determine the measure of a missing side length using Pythagorean theorem or using your trig functions. And you should be able to calculate the measure of a missing angle using your trig functions. Now, before we get into trig, we're going to take some time to just review some properties of triangles and some common conventions so that you're familiar with them as we move forward. Like I mentioned earlier, in Math 10C, we just work with right triangles when we're talking about trigonometry. As we move on to other courses in both math and physics, you will also start working with non-right triangles. Now, when we name triangles, we typically name them based on their vertices. So that first triangle could be triangle ABC. We could also call it triangle BAC or triangle CAB or CBA. The next triangle there is triangle DEF. Our vertices are typically labeled with uppercase letters, so capital letters, and the sides opposite the corresponding angle are labeled with lowercase letters. So when we're labeling our sides will have the same letter name as the angle that it's opposite. So if this is angle F, this would be side F. If this is angle D, I would have side D, and for angle E, I would have side E. Now notice again that the vertices are capital letters or uppercase letters, and the sides are lowercase letters. For our next triangle here, we would have side A, side B, and side C. The vertices of a triangle can help us to name the angles of a triangle. One way to do this is just to name the angle that is closest to the vertex. So we could call this angle A or angle B. We can also connect the vertices in a specific order, and that would also tell us our angle. So if I label angle BAC, that means I'm going from point B to point A to point C. So my angle would be right here. So this would also be angle A. Sometimes we need to do that when we have multiple triangles put together, because if I just say angle A, I don't know if I'm referring to angle BAC or angle BAD. Now later in this unit, when we start working with word problems, you're going to see angle of elevation and angle of depression used quite frequently. It's important that you understand the difference between the two. So angle of depression is the angle formed between the horizontal and our line of sight. I think about it as looking straight out, and as I look down or as I depress my eyes, that would be my angle of depression. Angle of elevation is the angle between the horizontal and our line of sight. So in this case, I'm looking straight out, and as I elevate my eyes, the angle between the horizontal and that line of sight would be my angle of elevation. Now, if you remember your parallel lines from grade 9, you'll notice that the angle of depression and the angle of elevation form alternating angles. So these angles are actually the same. The angle at which the person on top of the building would have to depress their eyes to see the person on the ground is the same angle at which the person on the ground would have to elevate their eyes to see the person up on the building. Now, something that's important to remember, but we often forget, is the number of degrees in a triangle. When I'm adding up all the angles in a triangle, that adds up to 180 degrees. Again, that will come in handy as we start working through some word problems. Now in math, you're often told how to round to the nearest tenth or hundredth. In trigonometry, our standard convention is to round our lengths to the nearest tenth and our angles to the nearest degree. So unless you're told otherwise, always try to remember to round your lengths to the nearest tenth and your angles to the nearest degree. It's important to note, though, that we don't round until the very end. As we get further into this unit, you're going to start working with triangle problems that involve more than one triangle, so you're going to have multiple calculations. It's important that you keep those numbers exact on your calculator until the very last step, so we only round our answer at the very end. Now, a quick note about mode. Up until now, mode has not mattered for you on your calculator, but when we're working with trigonometry, we're working with angle measurements, and angles can be measured in more than one unit of measurement. We can measure in degrees and we can measure in radians. In grade 10, when we're working with trigonometry, all of the angles that we're referring to will be in degrees. And that means that our calculator needs to know that we're using degrees as our unit of measurement. So we need to make sure the mode in our calculator says degrees. Now on a TI-83 plus or TI-84 plus calculator, you're going to choose mode, and then you're going to arrow down and make sure that degree is highlighted, and then you can just second quit out of there. Now, if you have other calculators like a Casio, for example, you may just have to look at your manual or do some research online. Now, whenever a Texas Instruments calculator is cleared, the default mode is radians. We actually use radians quite a bit in the later courses. So whenever your calculator is cleared, always go back and double check that your calculator is in the right mode. The only time that mode matters is when we're working with trig. So if you're pushing the sine, cos, or tan buttons on your calculator, mode matters. Now, when we're working with trigonometry, we will often also be using the Pythagorean theorem. And if you remember from junior high, the Pythagorean theorem says that the square of the hypotenuse is equal to the sum of the squares of the other two sides. So our general formula is a squared plus b squared equals c squared. So let's work through a few examples. Example 1 asks us to determine the length of the unknown leg in each right triangle. So I have my two short sides and I'm looking for my long side. My formula is a squared plus b squared equals c squared. So that would give me 5 squared plus 12 squared equals c squared. 5 squared is 25 plus 5 squared is 25 plus 12 squared is 144 would total to 169 and that equals c squared. Now in order to get c by itself, I would have to square root and that gives me c equals 13, and because we're rounding to the nearest tenth, 13.0 centimeters. Now, if you notice, our last step was to square root to get c by itself. A common mistake that I see students make quite often is they forget to square root and then they end up with the wrong length. So let me give you an alternative way to write this out. Since I know the two short legs and I'm looking for the hypotenuse, I know that I'm going to have to add. I also know that my last step is to square root. So I'm going to write x equals the square root of 5 squared plus 12 squared. Again, that's going to be 169, so the square root of 169. This happens to be a perfect square, and the square root of 169 is 13, and again, rounding to the nearest tenth would be 13.0 centimeters. For B, we have 16 as our hypotenuse, and one of our side lengths is 12, so looking for the other side length, we'll have x equals 16 squared minus 12 squared. Now, 16 squared minus 12 squared is 112, and then we just need to square root. On our calculator, we can do second square root, 16 squared minus 12 squared, and that gives us 10.58. Rounded to the nearest tenth would be 10.6. So for C, I'm looking for my hypotenuse. And if you remember labeling sides, opposite angle K would be side K. So I'm going to use K equals the square root of 13 squared plus 17 squared. Now putting that into our calculator, we could have second square root, 13 squared plus 17 squared, and that gives us 21.4. And our units are meters. Now for our last example, we're given the hypotenuse of 2 root 3, and we're told that both of our side lengths are x. So x squared plus x squared equals 2 root 3 all squared. X squared plus x squared is 2x squared. 2 squared is 4, and root 3 squared is 3. So we have 2x squared equals 12. Now we just need to get x by itself. So we can divide both sides by 2. That leaves us with x squared equals 6. And to get x by itself, we're going to square root both sides. So that gives us x equals root 6. Now that's an exact answer, so I could leave it exact. If I was asked to round to the nearest tenth, that would be 2.4. And again, we don't know the units, so we would write 2.4 units. So everything up until now has been conventions and just some review. Now we're going to get into the trig. The most important part about trigonometry is knowing how to label a triangle. I cannot stress that enough. The most important part about trigonometry is knowing how to label your triangle. In Math 10C, you're going to be given those formulas. Eventually, you're going to have them memorized. But if you know what your opposite, adjacent, and hypotenuse are, the rest just falls into place. Now in trig, we talk about 3 sides, and those sides are relative to the angle that's given to you. We often talk about that as our reference angle. The first side we're going to talk about is hypotenuse. Hypotenuse is always across from 90 degrees, so it's always relative to 90 degrees. Opposite is the side that is across from the reference angle that's given, or across from your acute angle. The adjacent side, remember adjacent in English means beside, the adjacent side is the side that is beside the reference angle that's given. Looking at our first example, we have our reference angle in the corner. Now you may not be familiar with that symbol. That symbol is called theta. It's a Greek letter that we use to represent angle. My hypotenuse is going to always be across from 90 degrees, so this would be my hypotenuse. And my opposite is always going to be across from the angle, so this would be my opposite. Now, if hypotenuse is on this side and opposite is on this side, the last one here would be adjacent. And notice this is the side that's beside the angle. For my next example, my angle is up in the top corner. Across from that angle would be opposite. Across from 90 degrees would be hypotenuse. And then the other side is adjacent. Now in trig, we're working with ratios for sine, cosine, and tangent, but everything is contingent upon you knowing how to label those sides. So if you mix up your sides, you mix up your opposite and adjacent, none of your ratios will work. What I'd like you to do is pause the video, try these on your own, and then come back and check your work. So across from the reference angle would be opposite, across from 90 degrees would be hypotenuse, and then we have adjacent. Once again, across from the angle is opposite, across from 90 degrees is hypotenuse, and that means the last one is adjacent. Now, when I was in school, I often mixed up opposite and adjacent, so this is just sort of a way that I've helped myself, always drawing my line across from the reference angle and across from 90, and that means the third one has to be adjacent. For the third triangle, across from the reference angle would be opposite, across from 90 degrees would be hypotenuse, and then that leaves this side as adjacent. Now, if you're looking for a game or a website that you can use to practice labeling triangles, one that I would recommend is Trig Mini Golf. Now, you can just go to Google and search for Trig Mini Golf, and it will pull up. This is a fairly old website. It's from Learn Alberta, but I'll take you through a couple examples. As you work through these questions, you're going to be given a reference angle, and then you have to identify what your side length is. So 5 meters would be my opposite, 10 meters would be my adjacent, and then we check. And then it says when we're calculating angle R, we would be using opposite and adjacent. So that would be tan. So tan of the angle is opposite over adjacent. Again, it's a little bit of an older site, so it's a little bit slower, but it really gets you in that routine of setting up your ratio. Now, because we have tan R is opposite over adjacent, that means that we're doing tan of the angle because we don't know what the angle is. My opposite is 5, and my adjacent is 10. And then we check, and they do the calculation for us. So again, the focus of this website is not doing the calculations, it's setting up the ratio. And then we hit continue. We get to take our first swing, and we're ready for question number 2. Like I said, if you're looking for a website or an opportunity to practice, this might be one to check out. So just as a refresher, when we're talking about our triangle properties, remember that all angles in a triangle add up to 180 degrees. Triangles with a 90-degree angle are called right triangles, and in grade 10, that's all we're going to be working with are right triangles. And the side opposite the 90-degree angle is called the hypotenuse. Now let's take a look at our primary trig ratios. In 10C, we just look at these 3. There's actually 6 primary trig ratios, but we're going to be talking about sine, cosine, and tangent. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. So you might be asking, well, what is a trig ratio? A trig ratio is just showing the relationship between two sides relative to your reference angle. So if I had an angle of 30 degrees, that would mean that the side opposite of 30 degrees is 1 and the hypotenuse would be 2. Now that could also be 2 over 4 or 4 over 8 or 6 over 12, but the relationship between my opposite and my hypotenuse for an angle of 30 degrees would be 1/2. If I type sine 30 into my calculator, I'm going to get 0.5. If I turn that into a fraction, that's going to be 1 over 2. Now what that means again is that if I have a reference angle of 30, my opposite side is 1 when my hypotenuse is 2. If I were to type in cos of 30, that gives me an irrational number. I'll just let you know that that's root 3 over 2. What that would mean is that if I have a reference angle of 30 degrees, my adjacent side would be root 3 and my hypotenuse would be 2. If I type in tan 45, that's 1. That means that my opposite and my adjacent are actually the same length. So if I have tan 45, that means my opposite could be 2, my adjacent could be 2. Believe it or not, you now have all of the tools that you need in your toolkit to solve problems for trig. Everything else that we do for the rest of this unit is going to be application. So how do we go about solving right triangles? First of all, if it's a word problem and you don't have a diagram, you're going to need to sketch your diagram. Second, you're going to label your triangle, and you're always labeling based on your reference angle. Step 3 is set up your ratio, and number 4 is to solve. So it's going to be label your triangle, set up your ratio, solve, over and over and over. Label your triangle, set up your ratio, solve. Let's get started with our primary trig ratios. Example 2 asks us to state the 3 primary trig ratios for angle A. Now, if this is angle A, this would be my angle. And we're going to label our triangle based on that reference angle. Remember, across from 90 degrees is hypotenuse. Across from the reference angle will be opposite. And beside the reference angle will be adjacent. Now, referring back to our primary trig ratios, notice that sine is opposite over hypotenuse, but it's sine of the angle. So whenever we're writing our ratio, we have to write sine and there needs to be an angle with it. If you don't know the angle, you would put the angle symbol. If you do know the angle, you would write that measurement. So sine of the angle is opposite over hypotenuse, cosine of the angle is adjacent over hypotenuse, and tan of the angle is opposite over adjacent. Now you'll notice on the side here we have SOHCAHTOA. SOHCAHTOA is a mnemonic device that you can use to help remember your trig ratios. So, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. So moving back to our example, I'm just going to write down that mnemonic device, SOHCAHTOA, and we're going to write out our trig ratios. So for sine, we have sine of the angle, and in this case we're talking about angle A, so sine of A is opposite over hypotenuse, so that would be 5 over 13. Cosine of A is adjacent over hypotenuse, so that's going to be 12 over 13. And then tangent of A is going to be opposite over adjacent, which is 5 over 12. So these are our primary trig ratios. They're showing what the relationship is. We can use that information to actually find what that angle is. Now in trig, we can find missing sides and missing angles if we have enough information. Notice that for all of these trig ratios, we have an angle and 2 sides. So as long as I have an angle and 2 sides and only one of them is unknown, I can find whatever it is that I'm missing. Example 3 asks us to determine the missing lengths for the given reference angle. For part A, I have a triangle with an angle of 54 degrees, a side length of 12.1, and another unknown side length. So the first thing I'm going to do is label my triangle. If you remember those steps, label your triangle, set up your ratio, solve. Label your triangle, set up your ratio, solve. So if I have an angle of 54 degrees, looking across the triangle, this would be my opposite. And beside my angle is adjacent. Now you can label hypotenuse if you want to, but it's not going to play a role in this question. Now the next thing I need to do is figure out which ratio to use. I'm looking for opposite. Sine has an opposite and so does tan. And I know my adjacent. Cosine has an adjacent and so does tan. Notice the only trig ratio that uses both opposite and adjacent is tan. So I'm going to set up my ratio. I have tan of the angle, so tan of 54 degrees is equal to opposite, which is x, over adjacent, which is 12.1. Now, in order to solve this question, I'm going to have to cross multiply. Notice that this is like having tan 54 over 1. So I can multiply 12.1 times tan 54. That would give me x equals 12.1 times tan 54 degrees. Notice that you're always writing that degree symbol in because it's a unit of measurement. On our calculator, we're going to first double check that our mode is in degree mode, and it is. And then we're going to type 12.1 times tan 54. Now you'll notice with some calculators, when you type in sine, cos, or tan, there's a bracket that automatically opens. Just be aware of that bracket. Make sure it's closed before you're multiplying by anything else. With some scientific calculators, you're going to find that they're what I call a reverse calculator. Instead of typing in tan 54, you have to type in 54 and then tan. That can become a little bit confusing. So getting familiar with your calculator is super important. So we have 12.1 times tan 54. That gives me 16.654. Again, we're going to round to the nearest tenth. So that's going to be 16.7. And we're talking about yards. So 16.7 yards. Moving on to our next example, we have 34 degrees, and across from 34 degrees is my opposite, and across from 90 degrees is my hypotenuse. So for this example, we're using opposite and hypotenuse. If I take a look at my trig ratios, the ratio that uses opposite and hypotenuse is sine. So setting up my ratio, I have sine of the angle, so sine of 34 degrees is opposite, which is x, over hypotenuse, which is 30.5. Once again, I'm going to solve by cross multiplying. and that would give me 30.5 times sine of 34. Now on your calculator, you can put this in either order. Just be aware of your brackets. So I could put 30.5 times sine of 34, or I could do sine of 34 times 30.5. What I want you to notice is if I put in sine 34 first and I forget to close my brackets, I'm going to get the wrong answer. However, if you look at the first step there, I didn't close my bracket and I still had the right answer. So again, just being aware for myself, I always put the 30.5 first so that if I forget my brackets, no harm, no foul. All right, so I have 17.055 rounding to the nearest tenth. That's going to be 17.1 and it's 17.1 centimeters. For part C, we're asked to find our hypotenuse, and given our reference angle, 12.5 would be our adjacent. So the ratio that uses adjacent and hypotenuse would be cosine. Setting up our ratio, we're going to have cosine of the angle, so cosine of 32 degrees is adjacent, which is 12.5, divided by the hypotenuse, which is x. Once again, we can cross multiply and divide. Notice that we're going to have 1 times 12.5 divided by cos 32. So that means we're going to be taking the 12.5 and dividing by cos of 32. On our calculator, that's 12.5 divided by cos of 32. And that gives me 14.7. So 14.7 inches. Now with regards to algebra, what you'll notice is that if my unknown is in the numerator, I'm just multiplying the other two numbers across from each other. If my unknown is in the denominator, then I'm dividing. Now that we know how to solve for missing side lengths, the only thing left to do is solve for missing angles. And guess what? The process is the same. Label your triangle, set up your ratio, solve. Label your triangle, set up your ratio, solve. So for part A here, we have our unknown angle. Across from our angle is 22. That's our opposite. And across from 90 degrees is 32, which is our hypotenuse. So for this ratio, we're using opposite and hypotenuse, which is sine. So we set up our ratio. Sine of the angle, so we don't know the angle, we're going to write theta. Sine of the angle is opposite over hypotenuse. Well, now how do we get that angle by itself? Your instinct might be to say divide, because that's what we do. It looks like we're multiplying sine by an angle. But we can't divide because sine is not a multiplication, it's actually a function. So let's take a look at our calculator. On your calculator, you'll notice that you have sine, cosine, and tangent. And right above there, we have a sine -1, a cos -1, and a tan -1. Those are called our inverses, so our inverse operation. So when I take the inverse of sine, that's going to allow me to get the angle by itself. So we can't divide by sine, but essentially that inverse is doing the same thing. And so for this question, to get the angle by itself, we're going to do sine -1, or the inverse sine of 22 over 32. So on our calculator, we're going to go second function, sine, that's how we get our inverse, 22 divided by 32, and that's going to give me an angle of 43.4 degrees. Rounded to the nearest degree would be 43 degrees. And let's take a look at one final example. Here I have my angle. This would be my adjacent and my hypotenuse. So in this case, I'm going to be using cosine. So cosine of the angle is adjacent, which is 7.6, divided by my hypotenuse, which is 9.2. I want to get the angle by itself, so I'm going to take the inverse of cosine. So cosine -1 of 7.6 divided by 9.2. On my calculator, second cos of 7.6 divided by 9.2. And that gives me 34.3 degrees. Rounded to the nearest degree would be 34 degrees. All right, so that's trig in a nutshell. Everything you need to know. Label your triangle, set up your ratio, solve. The rest of this unit is just going to be easy breezy applications. Have a great day, guys, and I'll see you soon.